Hi all, this is the final video talking about the process maze file. So there's one more update that we need to do to our maze. So firstly, in the last two videos, we have seen how to read this from a file, how to print it, and then how do we modify it so that we get the modified image. Now from this modified maze, we have to do an additional pre-processing or additional processing on top of it so that we get the updated maze image or maze image file. So let's see how to do this. So to achieve this, we have another function called increase maze size. So this function increase maze size, if we see this is kind of missing in the main function that we have. So somewhere here, we would be having a function like increase maze file. And to the best of my knowledge, this only accepts our vector of vectors, which is nothing but our maze file. And again, whenever we are dealing with all these things, we're dealing with pass by reference, wherein we are using address operator to ensure that we're not creating a copy in the function scope, or rather we are referring to whatever maze that we created inside our main function. Now, let's see how do we write this increase maze size, and we'll complete this part out, and then we'll see the move through the maze part. So now the task is we have to complete this function, and this function takes a two-dimensional vector of characters, which is maze, and this function should double the size of each row. So whatever the maze that we have generated, so this is our updated image. So whatever the updated image we have to modify it now. So we have one more step, which is modify it. So modified maze. So now the task here is that take the updated maze, and for every row, what we have to do is, so all the rows, they have the same number of columns. The number of columns doesn't change for each row. So somewhere keep track of number of columns. You can create any variable, keep track of number of columns in every maze. Now, this modified maze or increase maze size is a tricky method. If we are not alert, this method will end up eating all of our computer's memory. So let's be very careful when we are writing this modified maze function or increase maze size function. So the way we have to start is, or the way we have to do is, start with each row. So take the first row or the row at index 0, take that vector, and get the size of that vector. So store the size of the vector into a variable. So this size typically for maze 1 would be 12, because maze 1 has 12 columns. And now, once we have that, push back 12 items onto the maze. So push back 12 items onto the maze. So be careful, because the first time, when I said 12, that's for maze 1. And for all other mazes, you have to figure out what is the number of columns. So for maze 1, we have to add all these extra columns for the first row. So add extra columns for the first row. So the way we do it is, for each vector in maze, so for each vector in maze, now we have to write another for loop for each j in 0 to size of the current vector. So store the size into a variable and use that variable for size. Okay. So for each j in the size, push back onto the current vector. So what do we need to push back? Again, it's kind of, we have 3 rules for pushing back. So the rules are like this. If it's row 0, you push back hyphens. It should be all hyphens. The second rule, if it's the last row, again you push back all the hyphens. And the third point to remember, irrespective of the row number, so this was the last row, irrespective of the row number, the last column, so for all the rows, last column, it should be a pipe symbol. So these are the 3 rules. And then there are 1 or 2 more rules. I will see that quickly. So, sorry. I'll be continuing this on top of the code file. But yeah, let me write it here. The fourth rule is that for the Jimmy position, identify the corresponding spot. So the spot is nothing but whatever the columns that are there, you just add it. So this is how we do for the Jimmy. So Jimmy position is nothing but start position in the second maze. So in this second maze, we keep on tracking how Jimmy is moving through the maze. Okay. And rest all others, all the other spots will be white spaces or simple space. So all the others, I'm writing it here. Yeah. All other elements in extended maze will be spaces. That's it. So all of these would be spaces. That's how we do it. So the first row, last row, all hyphens, no matter which row it is, all the rows, the last column would be a hyphen, identify where Jimmy is, update the Jimmy's position with a start. This is like the corresponding or a copy of Jimmy's position on how Jimmy is going to track through the maze. And that's all. Yeah, remaining all should be empty characters or white spaces. So if I were to write the, clear it off. Yeah. So if I were to write this function, again, keep a track of something like pseudo algorithm or something, this will help us. So the steps are like this. Iterate through each of the vectors in maze. Okay. Now save the number of elements in subvectors into a variable. You can do all the, you can either have a single variable or you can keep on updating the variable. It's up to you. It's your choice really. And now again, iterate through the subvectors. So iterate through the, iterate through 0 to number of elements and push back a character onto the subvector. Now, what to push back is the question. So if we are in row 0, simply push back a pipe. If we are in the last row, do the same thing. Simply push back a pipe. If we are not in the first or last row, if we are in any other row, simply push back white spaces or a simple space character, but handle the last column. So handle the last column. And lastly, update Gmaze position on the ended maze as S. So these four should do the trick. And the return type for this method is void should do. We don't need to, return a Boolean variable for this one. So once we have this logic implemented here, what assignment requests you to do is you have to print this out. So total, we have to print before we do anything. We have to print the maze 3 times. The first time would be printing what we read from the file. The second one would be how we are showing the modified maze input. And the last one is updated maze. So maybe I have used the terms interchangeably here. This is something called as modified. And this is what we call updated. So do all these 3 steps, print it, and then we see how Jimmy needs to move across the maze. So that's this video. Thank you.